What's going on, guys? Let's look at this problem right here. This question is asking find the general solution to the given differential equation, and if you look at this differential equation, that is matching with this pattern. This is a linear second order differential equation with constant coefficient, and when we have linear second order differential equation with constant coefficients, we can apply this characteristic equation to find out the real roots. Now let's go ahead and apply that one. Before we do that, we have to write our a, b, c values. Here our a value is 1 and b value is -4 and c value is 5. Now let's go ahead and plug it in this equation. This is going to be r square plus b is -4, so this is going to become -4r plus c is 5, that's equal to 0. Now if you look at this one, this is not easy to factor, right? And when we have difficulty in factoring something, we use this equation. Here we have x is equal to -b plus or minus square root of b square minus 4ac divided by 2a. Since we are trying to find r, this is going to be r is going to be equal to -b, and in our case b is -4, so this is going to be -4 plus or minus square root of b square, that's going to be -4 square, minus 4 times a is 1 and c is 5, and in the denominator we have 2a, so this is going to be 2 times 1, and let's simplify this one. This is going to be 4 plus or minus square root of 16 minus 20 divided by 2, and that's going to become 4 plus or minus -4 divided by 2, and since we have a negative value inside of square root, this is going to be a complex number, so instead of -1 we plug I square, and that's going to make this one 4 plus or minus 2i divided by 2, and we can simplify this one as 2 plus or minus I, and that's it. And from this one we have the real number and the imaginary number. Here when we have complex number, our general solution for the differential equation is going to be in this pattern. Y of x is equal to c1 e power alpha x cos beta x plus c2 e power alpha x sin beta x. And here we have to know what is our alpha and beta. Alpha is the real number, that is 2 right here, and beta is the imaginary number. Here the value in front of I, that's 1, so that's going to be the imaginary number, that's going to be beta. Beta is equal to 1. Now we can go ahead and write our general solution for the differential equation. That's going to be y of x is equal to c1 e power alpha is 1, so this is alpha is 2, so this is going to be e power 2x cos beta x, beta is 1, so we can just leave it as x, plus c2 e power 2x, and sin beta x, that's going to be just sin x, and that's going to be our general solution for this differential equation. And that's how we do this kind of problems. I hope this helps. Thanks for watching.